Welcome to your first college algebra lecture video. First of all, to get started, let's go ahead and familiarize yourself with some of the things that you'll be seeing in the lectures. First of all, up in the top we always have the name of the class, and then down here we have what the assignment is associated with. So this is Unit 1, Outcome 1, or Homework 1. So to complete your Unit 1, Homework 1 homework questions on My Math Lab, these are the notes that are associated with that. This is the goal of the lesson. Students will be able to use exponent rules, simplify radical expressions on examinations, quizzes, and homework problems. Now, if you're looking for more information on this, you can look in our e-text that's in My Math Lab as well under P.2 and P.3. Those are sections at the very beginning of the book called preparatory sections. So this will be at the top of every one of your lectures. Also during this lecture, once in a while you'll see a calculator screen pop up. And the calculator screen is just basically me showing you how to use your calculators to help you do your homework and also get proficient with them so you do well in exams. So let's go ahead and get started with what we're working at today. What we're looking at today is called All About Exponents. So when we're talking about All About Exponents, the first thing we should probably do is talk about what an exponent is and what exponents are good for, and then some of the basic rules of exponents. Usually when we have an expression, let's say like x squared, x is called the base, and this 2 up here is called the exponent. Now the exponent could be an integer like this one is, it could be a fraction or a decimal as well. But when we're talking about exponents, this is what we're interested in talking about. Now why do we use exponents? Exponents end up being very large numbers, like the distance from here to the sun, or the distance from here to Pluto, or the number of molecules in a particular chemical expression or experiment, and very small numbers, like if we're trying to measure, let's say, the width of an atom. So exponents come in handy. It's a shortcut notation, and knowing how to work with exponents is one of the best skills that you can have working with algebra. So let's go ahead and look at basic rules of exponents. Now when we talk about the basic rules of exponents, we need to remember what the base is and what the exponent is. So remember this expression up here. Now when we talk about these rules, I'm going to use letters, and of course when we start working on homework problems we'll start to use numbers in place as well, but I want to make sure we can look at this generically. So our first rules of exponents is anything to the 0 power is 1. So anything to the 0 power is 1. This would be the same as something like 2 to the 0 is 1. You might say, well, why is that? Well, we actually need one other rule of exponents to explain that. And when we get to that spot where we can explain this, I'll make sure that we know what that is. So anything to the 0 power is 1. Now when you move on into calculus, if you move up to calculus, we're going to talk about not everything to the 0 power is 1 when we're talking about limits. And that's okay, because that's a different thing than working with these arithmetically. So we have anything to the 0 power is 1. We can also talk about an expression to the first power is just the base itself, because this is saying I have x written down one time. So anything that's to the first power is just itself. So if I had 2 to the first, that would give me a 2. Anything to the first power is itself. Okay, now we're getting to some of the other rules that are going to be helpful as well. What if we had something to a negative power? Well, if we had, let's say, x to the negative 2, the negative power basically means to flip the exponent. So this would say to take the exponent that's now in the numerator and flip it down into the denominator and make it positive. Well, another way we could look at this is what happens if we have something that's down in the denominator that's negative. So negative 4, we'll say. Well, this would move from the denominator up to the numerator. So a negative exponent means to flip. So a negative exponent implies that we should be flipping. With the exponent. Here, let's say we're multiplying some bases that are the same. So if you notice, both of these bases are x, the exponents are different. This expression is x to the a plus b. So what we talk about here then is when you multiply like bases, you add exponents. Now there's actually a really good reason for this. It's not just something somebody made up. So let's go ahead and look at why this happens. So if we were to put some actual numbers in here, let's say like x cubed times x to the 4th, we know x cubed, that means to take x and write it by itself 3 times. We also know what x4 means. x4 means x multiplied by itself 4 times, so this is x4. Now if we were to sit down and decide, okay, how many x's do I have here, we would say I have 1, 2, 3, 4, 5, 6, 7, x to the 7th. So wouldn't it have been faster if we would have just taken 3 plus 4 to get our 7? So this is just x to the 3 plus 4, x to the 7th. Now if you can't remember the rules, you write them out. You know, write down all your x's, see if you can come up with a shortcut rule if you can't remember them. So multiply like bases, you add the exponents. Now in order for this rule to work, both the exponents have to be the same. If the exponents are different, this would not work. Let's go ahead and do the same rule, except let's use division this time. So this one is when you divide like bases, what we do is we subtract exponents. Now we have to subtract them in a particular order. We have to take the numerator minus the denominator. When you divide like bases, you subtract exponents. Okay, so this is an interesting rule, and it goes after, just like we talked about up here, what we do with negative exponents. So let's go ahead and apply that. So if we have x to the a over x to the b, remember, with our negative exponent, I could take this x to the b and I could flip it up top. So this would flip up top, but when I do that, this becomes a negative b. Because remember, when you have a negative exponent, you need to flip it, either from the numerator to the denominator or the denominator to the numerator. And then we apply our next rule. When you when you multiply like bases, don't forget that there's an a here. When you multiply like bases, you add the exponents. So I have x to the a plus a negative b, which is just x to the a minus b. So that's our rule. When you divide like bases, you subtract exponents. Now this also gets us to the conclusion of, okay, well, what about that x to the 0 power is 1? Well, let's say we had x to the 4th over x to the 4th. Well, we already know anything divided by itself is 1, so let's start with that. And then here we also have realized that when you divide like bases, you subtract the exponents, so this 4 would pop up to be a minus 4, and I end up with x to the 0. And of course I have x to the 0, but we've already told you what this expression equals. It equals 1. So using that idea of dividing, anything divided by itself is 1, and then dividing like bases, you subtract exponents, help us to kind of define that anything to the 0 power is 1. So there's a few really handy rules for exponents that you'll definitely need to know. The next one that we're going to be looking at for our rules of exponents, let's say we had a base and an exponent, x to the a, on all of this was raised to the b power. So basically we have a power to a power here. Well, the rule is when you have a power to a power, you multiply the powers. Now the way I remember this is this parenthesis right here, that reminds me of multiplication, so that reminds me when I raise a power to a power, I have to multiply the powers. So that's our rule. When you raise a power to a power, you multiply the powers. Now this is a shortcut rule, so if we didn't remember it, we could do it longhand as well. So let's look at an example. What if we had x cubed quantity squared? Well, to square something means to multiply it by itself, so this would be x cubed times x cubed. And of course we know x cubed means to multiply x by itself 3 times. And here we have another x cubed, which would mean to multiply x by itself 3 times. And then, if I count up the x's, I have 1, 2, 3, 4, 5, 6, x to the 6th. So it would have been easier if I knew my shortcut rule, and this is the same as 3 times 2. When you raise a power to a power, you multiply the powers. Now at this point right here, where I had x cubed times x cubed, I could have also added the exponents because I have like bases to get x to the 6th as well. So another good rule to know. Another rule, if you have a product and I raise it to a power, that's the same as taking the power and distributing it to the individual factors in the product. Okay, so our shortcut rule here then is, so here we could say the power of this product and we say when the power of the product, what we mean is that xy to the a, we say that is the product of the powers. And that's kind of a tongue twister, but it might be something that you can have as a little saying that can help you remember these. Now the same thing's going to work with a quotient. So if I had x over y to the a, now I have to have these parentheses here and here. If these parentheses aren't here, then the base would just be the y. So this is x to the a over y to the a, and this is the same. This would be the power of the quotient. And we change this to quotient because I'm dividing. The power of the quotient, which in this case was x over y to the a, is the quotient of the powers. So this would be x to the a over y to the a. So that's another interesting little feature that we're going to be able to use that will make these expressions a lot easier when we're simplifying. And of course another thing that will make them a lot easier is when we actually put some actual numbers to these a little bit. Now one other thing that I want to look at before we get started working some actual problems are some cautions. One big caution is to be careful of what the base is. A lot of people mess up what the base is. So for instance, if I had 7 squared, that means 7 times 7, I get 49. Now the base here is clearly 7. Now let's write this expression, negative 7 squared. Well, in this case, the base is 7 as well. So this is a negative sign out front, and then I would do my 7 times 7, and I'd have a negative 49. Now the reason that only 7 is my base and not the negative is the 2 only goes to directly what's in front of it unless there's parentheses. So if we put the negative 7 in parentheses, that would be a negative 7 times a negative 7. A negative times a negative, of course, is a positive. 7 times 7 is 49. So I get a positive 49 out of that. So you can see you have to be very, very careful about what is the base of the exponent. That's what we really want to look out for here. Okay, for the rest of the lecture, let's just go ahead and focus on working on some types of problems that you'll see in your homework set. So we'll put down some problems and we'll talk about which rule applies and then how you can simplify to make sure that you match the correct solutions that will be required from you in My Math Lab. Now when you're working in My Math Lab, one really important thing that you need to remember is get a tablet, write down the problems and show your work, because you're going to be taking quizzes, and if you have your work shown from your homework, then you have a really good resource of things to go back to and check while you're taking your quiz. So all your work has to be written down. If you don't write it down, what ends up happening is you don't really retain the information as well, and to be successful on an exam, that's a really good way to practice, by writing things down. So let's just go ahead and start with some basic problems. Let's try 5 squared times 5 to the negative 5th, let's say. Okay, so here's my rule. We have like bases, so when you multiply like bases, you add exponents. Now if you want to think of adding a negative number is the same as subtracting, I get 5 to the negative 3. Now, in math, we usually do not leave negative exponents. We always try and rewrite these. So this would be 1 over 5 to the third. And 5 to the third now is something that we can figure out. Let's go ahead and pop up your calculator. So here we do 5, and then over here on the right-hand side we have an exponent key. Now when you use the exponent key, sometimes you'll see a caret symbol, and sometimes it'll actually move up into the exponent, so it depends on which calculator you have. So I have 5 to the third, and I hit enter, and I get 125. Now another thing that you could do, so over here I could write 1 over 125, which is my final answer. Another thing that you could do with your calculator is you could actually do 1 divided by 5 to the third. Now if you do that, you'll get this decimal, but you can change any decimal, actually not any decimal, but most decimals, to a fraction by hitting over here on the left hand side, math, frac. It's your top number here, number 1. You can either hit enter or the number 1 on your keyboard and hit enter, and then you can see it goes 1 over 125. Now we can do the same problem that we just did from the beginning on your calculator too. So to check your work, you could do 5 exponent 2. Scoop this up a little bit. And then you have to move out of the exponent, so I hit my arrow to the right, times 5 exponent negative 3. Now in your calculator, this is your minus sign, and that means subtract. This is your negative sign. So this goes in front of a number to show that it's negative. This goes after a number to show that you're subtracting. So 5 to the negative, what did we say? Negative 5. Enter. And you see I get that 0.008, the same I did here, but again you can change it to a fraction by hitting math and then choosing 1 for fraction and hitting enter to execute the command, and you get 1 over 125. So this is a really good way to check your work. It's not a good way to do your work, meaning you don't want to just do calculator work. You actually want to write down the problems and show your work like we did in this example. Now we can also do some problems. This is a product because we're multiplying like bases. We could also have something with a quotient. We could have something, let's say, like, let's do 3 squared over 3 to the 5th. Well, our rule here is when you divide like bases, you subtract the exponents. 2 minus 5 is negative 3, so this would be 1 over 3 cubed. Now 3 cubed means 3 times 3 times 3. So 3 times 3 is 9, 9 times 3 is 27. So this is my solution. But again, if you want to on your calculator, you can pop it open and do 3 squared divided by 3 to the 5th to check your work. 3 squared, and remember you have to get out of that exponent. And every calculator is going to be slightly different, so you'll just have to kind of get used to what your calculator is versus what this screen is showing. So here I have 3 squared divided by 3 to the 5th. Now here's my decimal, and let's see if this will convert that to a fraction. So math, frac, enter to execute the command, 1 over 27, which is what I thought the answer was from my work over here. So again, it's a good way to show your work, not do your work. Always check your answers when you can. We could also have an expression, let's say like x, y to the negative 2. And they might want us to just rewrite this without negative exponents. Well, in this case, rewriting this without negative exponents, the important thing is to identify what the base is. Now here, the base of the negative 2 exponent is only the y. So the x stays and the y goes. And because it's a negative exponent, it will flip. Now let's contrast that with this expression, xy quantity to the negative 2. Well, this would mean that they would both flip, because if you notice these parentheses indicate x and y are both my base. So I'd have 1 over x times y quantity, has to be in parentheses, squared. Now the reason it flips is because I have a negative exponent. Another example we could look at when you raise a power to a power. So we could have something like x to the negative 3 quantity, all of this to the 4th power. Now remember, when you raise a power to a power, you multiply these powers. Now the way I try and remember that is this parenthesis right here reminds me of multiplication. So this would be x to the negative 3 times 4, x to the negative 12, and we never leave negative exponents, so we flip that into the denominator. So again, our rule here is when you raise a power to a power, you multiply the powers. Now this rule can be provided for problems a little bit more extensive as well. For instance, I could have a really long, in-depth problem with constants or coefficients like this 4 and this one is negative. I could have x's and y's. So I could get a really ugly problem here, and what I can do with something like this is just combine like terms. So here are my coefficients. So here's the negative 4 and the negative 2. Then I could look at my x's. So this would be x cubed times x to the 5th. And then I could group my y's. So here I have just a y and a y to the negative 3. So if I group my like terms, coefficients and variables, these are a lot easier to work. Now here I have negative 4 times negative 2 is 8. Here, x cubed times x to the 5th would be x to the 3 plus 5, because remember when you multiply like bases you add exponents. And on my last one I have y times y to the negative 3. Now there's no exponent here, but it's an implied 1. So this would be 1 minus 3. So simplifying, I have 8 x to the 3 plus 5 is x to the 8th. Y, 1 minus 3 is negative 2. And then of course I'd rewrite this without any negative exponents, and I would flip just this piece. Everything else stays because the negative 2 only goes to the y. So I have 8x to the 8th all over y squared as my solution. Now this one we can't really check too much on the calculator because I can't do variables very easily with the calculator. So when we're simplifying these expressions, just like it says, just very carefully rewrite, simplify, combine like terms, and never leave your answers with negative exponents. Let's look at one that has a quotient and is a little more complicated. So let's do something like 28 x squared y to the 5th all over 21 x to the 5th, and then let's do a negative exponent down here in the denominator. And I'm going to do the same thing as before. I'm going to group my coefficients together. I'm going to group my x's together, and then I'll group my y's together lastly. So this would be y to the 5th, y to the negative 3. Now 28 over 21 doesn't look like much, but these are both divisible by 7. So 7 goes into 28 4 times, 7 goes into 21 3 times. So for this first one I'm left with 4/3. Now for my next one, remember when you divide like bases you subtract exponents. So this 5 I would flip up top and it becomes a minus 5. And for my last one, this is going to be a little bit trickier. I have y to the 5th and I flip the negative 3 up. So I have to go minus a negative 3. Okay, it's a minus sign here because I'm subtracting a negative 3. Now the 4/3 doesn't change. 2 minus 5, my exponent here will be x to the negative 3. And then over here, lastly, this is going to be 5. When you subtract a negative, it's the same as a positive. So 5 plus 3 would give me that value for 8. Now when I'm simplifying this, this is the only part of this expression that will flip because it has the negative exponent. So the 4 stays in the top, the y to the 8th stays in top, the 3 stays in the bottom, and the x cubed flips down into the denominator. So this is my simplified expression. Now everything that we've been looking at so far, my values in the exponent have been integers, but that's not always going to be the case. So one thing that we're going to start talking about are radicals. Radicals mean like square roots and cube roots. So let's go ahead and look at what radical notation looks like. So this is called the square root of x. This is called the cubic root of x. This is the 4th root of x, 5th root of x, etc. Now the way I would rewrite these in exponential form, this is called square root. Square implies 2 sides, so this would be x to the 1/2. Now the 2 is in the denominator because that is the root. The cubic root of x would be x to the 1/3. The 4th root of x would be x to the 1/4. And the 5th root of x would be x to the 1/5. So this basically, let's say the 5th root of x. This means what number do I multiply by itself 5 times to get x? So that's x to the 1/5. Now when we combine something a little more complicated, let's say we had the 8th root of x cubed. Now we already know that the 1/8 will come into play for my root, but this 3 goes in the exponent. So this is my power, and this part is my root. And sometimes we'll be combining these. So in these next few examples, let's go ahead and look at how we'd simplify some of these expressions. Let's look at the negative square root of 64. Well, the negative sign is out front, so we just drag it along, and the square root of 64 is just 8. So my solution here is negative 8. Now, square root of 64 is 8. That means 8 times 8 is 64. And if you have troubles with your square roots, remember, you can always go back and double check on your calculator. Now, square root on your calculator, it's right here, this little blue that's up above, so you hit your second key, second square root, 64, and hit enter, and we get 8. Now, another thing that we could do here, remember, we just talked about how square root was the same as an exponent of 1/2. We could put 1/2 in the exponent, and we would get 8 back as well. Now remember, this had a negative sign out front, so if we wanted to see what a negative square root of 64 was, negative sign, not the minus sign, and then we could do the square root of 64 or 64 to the 1/2, either one. And you can still see here that we get a negative 8. So there's a lot of ways that we can simplify and check solutions here. Now I'd like to contrast this one with the square root of a negative 64. Now there's no way that I can multiply a number by itself and get a negative number back out. Not in the real number system. In the complex number system that we'll work with a little bit later in this semester we can. Let's just try and see what happens here when I try and take the square root of a negative 64. It says error, a non-real solution. That means that there could be a solution, but it's not a real number. Okay, so our answer is going to be over here, that our solution is not a real number. If I take 8 times 8, I get 64. If I take negative 8 times negative 8, I get a positive 64. So I have to be really careful here. Square roots of negative numbers I can't do. I could take the cubic root of a negative number though, because odd roots I can have negative values under the radical sign. Let's go ahead and look at another one, negative 12 quantity squared, square root of negative 12 quantity squared. Okay, so what we want to think about here is I'm trying to take the square root of something squared. They kind of cancel each other. So the fact that this is a square root and this is squared kind of cancel out in a way. And my answer here ends up being the absolute value of what we're going to call the base of the radicand. And the absolute value of negative 12 is 12. Now, let's go ahead and double check this on our calculator to see what it thinks. Now, some of the things that we're doing in class, the calculator is not going to be so great at. So that's why it's also important that we know how to work these types of problems. Okay, calculator's good with this. What it did is it took negative 12 times negative 12 and it got 144. And the square root of 144, of course, is 12. So that's another way that we could think of this same thing. Okay, now what if we have an expression where we're asked to simplify a base, let's say to the negative 2/3. Now remember, this is the power and this is the root. So we're used to combining these, but we're going to pull these back apart. So for here, I would like to look at this as 8 to the 1/3 and then to the negative 2. Well, 8 to the 1/3 means the cubic root of 8. So this means what number can I multiply by itself 3 times to get 8? Now our answer is 2, but let's go ahead and check that out. 8 to the 1/3. So 8 exponent, And then of course if you you use your caret key here, you need to use parentheses. If you see, goes up into the exponent, so I don't need to worry about that. But if yours doesn't, you need to use your caret key. The cubic root of 8 to the 1/3 is 2. So this piece right here simplifies to 2. 2 to the negative 2 is 1 over 2 squared, which is 1/4. Now let's see how your calculator would handle this if we just went 8 exponent to the negative 2/3. So 8 exponent, and remember if you have a caret key that shows up here, you need to make sure you use your parentheses, 8 to the negative 2/3. Well, 0.25, my math lab is going to want a fraction, so we'd have to convert this to math, frac, and there's our 1/4. Okay, so it's really important that you double check your work. You do it by hand and then you check it with your calculator, but don't just rely on your calculator for everything, because you need to be able to work these by hand as well, because some problems are not workable with the calculator. Okay, sometimes we look at radicals and we can't get to an exact answer. So we're going to have to look at some of those more difficult problems that you'll run into in this homework set as well. Let's look at 243 x to the 15th, y to the 25th. And this is all to the 1/5 power. Okay, well this is the rule where I have a product to a power. A product of the power is the power of the products. Okay, so that basically means take the 1/5 and distribute it to each factor. Now this doesn't work with addition or subtraction. Notice we only did this with multiplication and division. So this is going to be 243 to the 1/5, x to the 15th to the 1/5, and then our last one here, let's do y to the 25th to the 1/5. Now 243 to the 1/5, that means what number do you multiply by itself 5 times to get 243? Well, let's grab our calculators here. 243 exponent and then 1 divided by 5. 3. Okay, if I multiply 3 times 3 times 3 times 3 times 3, I'll get 243. So my first expression here is just a 3. Now in the purple here, x to the 15th to the 1/5, remember when you multiply like bases you add exponents, but when you raise a power to a power you multiply exponents. And the same will hold true, y to the 25th to the 1/5. When you raise a power to a power, you multiply the powers. 1/5 of 15th is 3, so that would be x to the 3rd. And if you're not good with your fractions, remember, grab your calculator. 15 times 1/5. So I'd have 15 times 1/5, and I want to put this in parentheses to make sure I'm multiplying correctly, and I do get my 3 here. Now my other one that I see from over here is 25 times 1/5. 1/5 of 25 is 5, but if you need to check that, you go 25 times 1/5. And we get our 5. So then we can simplify this expression, x cubed y to the 5th. Now nothing needs flipped here. I don't have any negative exponents, so that would be my final solution. So simplifying is a really, really important skill to have. Now sometimes in my math lab you're going to be given a problem that seems so difficult or so ugly that you can't simplify it. But you just really need to think about starting with the basics, and then once you get started applying each of the smaller rules, as you work the problem will get a little easier and a little easier. So let's go ahead and look at an example where we have a lot of exponents. Some are positive, some are negative, and then I all have it raised to a power. Now there's more than one approach that we could take here. We could distribute the negative 8 first, or we could simplify within the radical first. So it's kind of your call. I am going to simplify within the radical first because I have x's that should simplify or cancel. So I have x to the negative 3/4 minus a negative 1/4. Because remember, when you divide like bases, you subtract the exponents. And this is all to the negative 8. Well, minus a negative is the same as a positive. Negative 3/4 plus 1/4 is a negative 2/4. So this is x to the negative 2/4, y to the 1/4, all to the negative 8. And of course, negative 2/4 is the same as negative 1/2. And then I can take the negative 8 and distribute it. And I have a negative times a negative is a positive here. So I have negative 1/2 times negative 8. And here I'll have 1/4 times a negative 8. When you raise a power to a power, you multiply the powers. A negative 1/2 times a negative 8 is a positive. Half of 8 is 4. And then a fourth of 8 is 2, but a positive times a negative is a negative. So I get y to the negative 2. Now if you're not good with your fractions, grab your calculator. I will not leave this answer as is. You couldn't sleep at night if you did, because you never leave negative exponents. So I have x to the 4th over y squared as my solution. So even though they're really ugly to start with your basic rules of simplification and work from there. Now sometimes you'll be asked to simplify an expression that I can't simplify all the way down. So for instance, the cubic root of 16. Well, that would be the same as 16 to the 1/3. Make sure you use those parentheses if you have your caret key. If you notice, this doesn't convert. I could try and change this to some sort of a fraction. That's not really helping me either, because it's a number that doesn't change to a fraction. So I'm going to have to simplify this by hand. So I have the cubic root of 16. Well, 16, I could break down 16 like a prime factor. That's 8 times 2. And 8 is 4 times 2. And I drag along this 2. And 4 is 2 times 2. And then I drag along these. And so I have 2 times 2 times 2 times 2 here. Now if you notice, I have 2 to the 3rd power. So that would be the cubic root of 2 to the 3rd. And then this other 2 I couldn't really do anything with, and that's the cubic root of 2. Now the cubic root of 2 to the 3rd, these 3's cancel each other, because I will rewrite these, and this would be 2 cubed to the 1/3 times the cubic root of 2. Got to drag that along. Remember, when you raise a power to a power, you multiply the powers. 3 times 1/3 is just 1. So another way we could look at this same problem is if these 3's cancel. The root and the power cancel each other out. Now we've worked on a lot of problems today in this, and hopefully you can kind of go through and look through these again if you need help with them. Now we didn't do every single type of problem that you'll see, but we did most of what you'll see, and you'll be able to apply the rest of the other problems that you'll run across. You'll be able to apply the rules of exponents that we learned today as well. So good luck on your homework. If you have any questions, please feel free to bring them to class or to email me or stop by my office. Have a good day.